So here's an example to talk about finding the HCF and the LCM of polynomials. But before doing that, let us start with just some regular numbers, just to revisit how to do that back in primary school. So in order to do that, for each of these numbers, we have to break it down into a product of prime factors, okay, in index notation. Okay, that's what we've done it in S1, right? And for HCF, what we need to do is we look for the common factors here, 2 and 3, but not 5 because it's not common, right? So for 2, we take the lower power, that is 1. And for the 3, we also take the lowest power, that is also 1. Okay? And so HCF is 6. Now, on the other hand, for LCM, you want everything. So for the 2, doesn't matter whether it's common or not, and you take the highest power. And 3, you want the highest power, and this time, even though 5 is not a common factor, we still want it. So we want everything the highest. Okay? And so it's 360. Now in the world of polynomials, just like regular numbers, to find HCF and LCM, we need to break all these 3 polynomials individually down, just like these numbers, into factors. Okay, so in other words, we have to factorize each of them. So for each of these polynomials, you completely factorize them, and even the constants, the coefficients here, are broken down into prime numbers, prime factors, and this one in index notations. Then you can do the same thing for HCF and LCM. So for HCF, you look for the common things only. Okay, this one has x plus 3, x plus 1, but this one doesn't have x plus 1, so we cannot take that. And this one doesn't have x plus 2, x plus 3, so none of these are common factors. X squared, x are also not common factors. So that leaves us with just the numbers. Okay, only 5 is common, and remember, we take the lowest power of the common factor, which is 5 only, and so the answer here would just be 5. Okay, and for LCM, it's the other way around. It doesn't matter whether it's common or not, we just want everything with the highest power possible. So here you go, and you just need to put this back together. Okay, you don't need to expand this. Okay, so here's the key. To find the HCF, you always look for the common factors, that this factor has to be present in every single polynomial. And also, for each of these common factors, what do? You take the lowest power that is present. Okay, and on the other hand, and for LCM, you need to take everything. Okay, every single factor, and for each of them you take the highest power. Okay, so let's say I have 3 sets of polynomial here, 1, 2, and 3 after factorization. Okay, and if we want to find the HCF, we would look at the common ones, just this and this, nothing else. And for P, we take the lowest power, that is 1. And for Q plus 1, we take the lowest power, that is 2. So here's the answer. And for LCM, we want everything. We want P, but to the 3rd power, because we want the highest. We still want Q minus 1, even though it's not common, and we want the highest powers, 2. And Q plus 1, we take 3, and Q, we take also the power of 3. So here's the answer. At the end, we just want to put this back into the front to make it look better.